So this problem, a force gives me the x and y components of a force. So when you see I hat or j hat, I hat means x direction, j hat means y direction, right? That's all that means. It's a unit vector, right? It's beyond kind of what we're doing, but you know what it means now. So I have it undergoes a displacement of something in the I direction and something in the j direction and something, the forces, some in the x and some in the y, right? Okay, so let's draw this out because they're just vectors, right? So this force is 6 in the x and minus 2 in the y. So I'm going to draw my force vector. So my force vector is going to be 6 this way and 2 down, right? So my force vector is going to kind of look like that. So this is F. Right, so this right here went 6, and this right here went 2. I called it minus 2 because, or I drew it down because it's minus 2. So there's F. And then S is 3 in the x and 1 in the y. So from here, x is going to go 3 in the x and 3 in the y. So it's going to look like that. Right, no, it's 1 in the y. 3 in the x, 1 in the y. So 3 in the x, 1 in the y. So it's going to look kind of like that. So 3 and 1. And this is S. And S just means displacement, right, instead of x. Okay. So find the work done by the force on this particle. So I could do this two ways. I could either do Pythagorean theorem to get F, do Pythagorean theorem to get S, put those two together, right? So F goes here, S goes here, that's F, this is S, and then find the angle between them and then do F times S cosine theta to get the work, right? Because work is force times distance times cosine of the angle, right? I don't want to do that, right? I'm going to do it the easy way. So let's do my x components and my y components. Just treat them like vectors, right? So here's my x, here's my y. So my force in the x is 6 newtons, and my displacement along the x direction is 3. And in the y, my force in the y is minus 2. I got to have the minus, right, because that's signifying the direction. And then my s in the y is 1. So for each of these, force times distance, which is s, is going to equal the work, right? So the work is going to be the product of these two things. 3 times 6 is 18. Work here. Negative 2 times 1 is negative 2. So my total work is going to equal 18 plus negative 2. 18 plus negative 2, which is 16 joules. That's a lot easier than doing a bunch of trigonometry, right? And it comes from the fact that vectors, you can always decompose them into their x and y pieces and solve them that way, right? Makes it a whole bunch easier. Okay, find the angle between them. So now what I need to do is these two triangles here, I need to find this angle, because that angle is going to give me this angle between the two, right? So I'm going to draw that again. So S kind of points here, F kind of points this way, and here's the XY plane. I need this angle. So if I could find the angle here and the angle here, I can just add them up, right? Easy. Okay, so to do that, let's just come over and look at these two triangles and use tangent. So if I come over here, the tangent of opposite over adjacent would give me the length, right? I'm sorry, the angle. But I want the angle, so I'm going to use inverse tangent of opposite over adjacent to give me my angle, right? Because remember, tan theta is opposite over adjacent. So angle gives you ratio. So tan of an angle gives you a ratio. If you take the inverse tan of the ratio, that'll give you the angle, right? The inverse tan just switches angle and ratio, right? So I'm going to take the inverse tangent of opposite over adjacent. So I'm going to take the inverse tangent of 2 over 6. I'm not using the minus because that's just signifying the vector direction. The actual length of it is 2. So the inverse tangent of 2 over 6, if I do that in the calculator, second tangent, 2 over 6 is 1/3, right? So I'm just going to do 1/3. 18.43. So that's 18.43 degrees. So that's that one. And then over here, same thing. Inverse tangent of opposite over adjacent, right? Here's my angle. So, oh wow, look at that. It's the same proportion. It's 1/3, right? This one was 2/6, that one's 1/3, so I lucked out. So it's also going to be 18.43. So 18.43, 18.43. That means my total angle is going to be 2 times 18.43. So what's that? 18, 18, 36.43, 86 degrees. That's my total angle. So to do the first part, break your vectors into x and y pieces, right? And then to do the second part, to find the angle, use our trig functions like we've done. Take these sides and solve for an angle, and then it's just the angle between the two vectors.